Okay, hello everyone. This is Sayyid Junaid Ali. Uh, now, everybody talks about the programming languages in applied maths and everything, and we know that those people only do the programming and something like that, and those kind of stereotypes. So today I'm gonna talk about what kind of a programming language we or like a software we use as a pure mathematics person, and how we do abstract algebra and something like group theory in 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 any software way. First, I'm going to talk about that we call it gap. So there's this software which you can install on Windows and iPads, MacBooks, not iPads, but MacBooks, and then on Linux and like all these three. And to do that, what can we do is a simple search in in simple search, what is is that we go to we go to we go to Google and I should write. So we go to Google and type Gape software. And that is, we will start here. And this is Gape groups, algorithms, and programming. And to download the Gape, how to obtain Gape, current version is 4.14.0, released on December 5, and it can be obtained from our install page. Now there are these three options: Linux, Mac OS, and Windows. Now I'm using iPad, MacBook, so I'm gonna use this, but I have already installed this, so I don't need to download. You'll just click this and it will give you these two options: a zip folder or a tar.gz, and then you will click it, it will download it self, and then everything will work similar way. So you don't need to do anything else. Then when you download, after downloading, you will have something like this. So this is gap here, and this is gap here, and then it will appear like this. Perfect. Now, how we use it, what it is actually. So the user interface is in front of you guys, and then how to do the basic interaction. So let's say you can add things. So you write operation, again number. Now this is something semicolon to run this command, and it will give me the answer. You can add, multiplication is a star. So like some basic kind of programming syntax is used here. And so enter is for running the program or the command. So something like this, you can give powers. Power is with this hit. So 1 power 3 plus 12 power 3, and this will give you this number. And if you want to do the other, 9 power 3 plus 10 power 3 and semicolon. This is same. Now, if you want to make sure that two equations have similar order, you can copy the things in here also, and you can use equals to other command, and it is true. Okay. The Boolean operations and, or, and not are frequently useful. So not something like this will also work in here. It's true. And so variables and assignments, so any object or the system result can be stored in a value in a variable. Like a variable can be thought of as a name which points to a particular object that has been computed. So something like you said first perfect number is 6, and you assign to first perfect number. Now you can use this first perfect number. So let's say I'm gonna add 22 to this first perfect number, and semicolon. So it's just used first perfect number as a variable and you added 22 to it. Now note that GAPE language is not typed, and thanks to a built-in garbage collector does not require the declaration of the types of variables. Okay, so you don't need to worry about that. Now functions. A function takes as input one or more arguments and may return some outputs. So GAPE has many built-in functions. For example, is prime. So let's check. Remember, first letter is capital, then small, then capital, then small letters, and now you are checking that 2 power 13 minus 1 is prime or not. And the answer is true. Moreover, let's just start with simple one. So yeah. Okay. Now many more functions are built into GAPE. For information on these, consult the GAPE help file by typing a question mark followed by the name of the function, or in GAPE, click help on the menu bar. So if you want to this, it will generate something like this, and you can go through all of these. So if you want to check about anything, these are directories, and this is GAPE help, and you can learn about these in here and then try to do something in the programming in the console. Okay. Then additionally, you can define new functions. So a function can be defined by writing the word function followed by the argument and ends with the word and. The word return will return output. So for example, we can make a function that adds 1 to an integer. So let's write a function. So we named it add1. Now function, it takes x, return x plus 1, and so I could have written it like this, and then return x plus 1, and this semicolon is to give this command as a command. Okay, and then I would end this function, and we have defined a function. Now what was the name of the function? The name was add1. So add1 is a function which takes a value. Okay, let's give it 5, and then it's gonna add 1 to the input. Okay. Similarly, a useful shortcut is to type the input followed by an arrow, written with a minus sign and a caret, followed by the output. This has the same effect. So that means you can remember we give semicolon, we give colon and equals to define something, and then we said x, then we give minus sign and then caret to say something, or which is an arrow in here. And then this is nothing but you define a function which has which is again a same function. So if you do 815, similar. 876, it's 7. Okay, nice. Now we talk about lists. Now list, one can group several pieces of data together into one package containing all the data by creating a list. A list is started with a left square bracket, so ended with a right square bracket, and entries are separated by commas. The command length returns the number of entries. The very simplest list is an empty list. So let's call it small l, and this is an empty list. Okay, now let's use the command length, and we are trying to find length of this empty list, which is 0. Now, to access a particular entry in a list, square brackets are placed around a number after the list. Okay, so for the first entry, 2 for the second entry, and so on. So let's create a list. So L was an empty list. Now let's put some elements to it. We say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. And we have a list now. Now, if you want to call any number of the list, let's say L of 10, that is 0, because at the 10th place, the number which we have stored in the list is 0. Okay, that's how you call the number particular element of the list. The same notation can be used to assign entries in a list. So let's say now this is the 10th number, and now we are saying it is actually 10. Okay, now let's call it again. Now it is 10. Now let's call a list. You see, this is we have assigned the 10th element in the list 10, and that's just replaced 0 by 10. Perfect. Now you can also check the membership of elements in 10 in the list. So let's say 2 in L, true. Let's say 11 in L, false, because 11 is not inside it. You want to know the position of some element in the list? Let's say position. Remember, first letter should be capital. Position. Now take the position. What you do, list, and then the position. So let's try to know the position of 5, which is actually at this time 5. But let's write another list. So let's now write capital L, and we have 1, 12, 13, 22, 33, 44, 24, 3, 4, and so on. Now we have a list, and then we want to use the position function. Now we have a capital L as a list, and then 5. Now 5 is not in the list. 22. 33. Okay, 33 is at 5th position in the list. Perfect. Now let's call the 5th number in this list. It's going to be 33. Okay. Now, with the add command, you can add elements into the list. So capital L. Now, what do you want? You want to add some number to it. Let's say 0. You have just added 0 to the list. And it's going to end at the last position. Okay. In the new last position, append adds all elements of the list L2. So append adds all elements of the list L2. So that means list 2. So that means append is a command which adds a list to the list. So let's say we have L and we have another else, but with the same small one. And now you have appended, you have added all of the small list L, which has elements 1 to 10, into the capital list L. So let's call the capital L, and you see we have also added 0 to the capital L list, and we have also added 1 to 10 elements, which was the another list. Okay, so append adds list to a list, add L elements to the list. Perfect. Now the braces can be used to create sublist of a list given by a list of index positions. Okay, so let's call L, and then now we use these braces, and then these are the positions. So 3, 5, 8, say suppose. And now 3, 5, and 8 are the elements, and this is a list. So number 3 position is at 13, number 5 is at 33, number 8 is 24. Okay, so this is how you can create small list from the existing list. Perfect. A special case of the list are ranges that can be used to store arithmetic progressions in a compact form. The syntax is start and then end for increment of 1 respectively, and then start, second, and end for increment of size, second, and start. And in the following element, the surrounding list is going to be something like that. So let's say we take, so now list is a function which takes a list and then keeps everything to itself. But let's say we are squaring or like just adding 1 to them. So this is going to add 1 to every element from 1 to 10. And that's going to 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. That means you can take a list using this list function. You can take a list and then you can do something. You can give an argument to do something to those elements. Okay, and this is there you are using the range thing and then also using all of the elements from the list. Now similarly, you can start, let's not start from, you can start from anywhere. That's going to do this because we are using the function x plus 1. You can change the function and say, let's say x minus 1. That's going to do something like this. And then, so why I'm doing this? Because to use groups and everything in this abstract algebra course for a programming person, if you are using any kind of language, programming language to do abstract algebra or representation theory, you need to learn these things to understand how you do computations in the pure mathematics. Okay, perfect. Similarly, you can write arguments like this. 1 comma 2, and then 2 goes to 10, and then subtract. So it has subtracted from everything, so something like that. It's easy. And then it when using this function which we have used here, we can also do something like the range. So if you have a list already, and then write you want to take the elements from that list, but you want to give the range to those. You are not particularly defining the positions, but you are giving a list is the position. So this is gonna take element from position 3 to position at, and that are those elements, something like that. Okay. Now list themselves are pointers to list. Assume assigning a list to two variables does not make a copy, and changing one of the list will change the other. You can make a new list with the same entries using shallow copy. So let's say we have this list. Here's 1, 2, 3 elements. And now if you don't want the result, you can just put two semicolons and it's gonna just not show you anything. Now we are copying A and calling it B. So B is also the same list. Now let's say C is a shallow copy of A, and it is C. Now the second element in A, we are calling it 4. So it's going to append the second element is 4. Okay. Now we are calling all of these lists. So see, so you have changed A when you add that when you give this command, which is that change the second element in the list A equals to 4, it has also changed the second element in B. So when you are doing this, you are not writing another list. You are actually just writing that A and B are same list. But when you use the shallow command list, it doesn't it gives you this another list actually of same numbers but like another list. And when you do something to the first list, it's not going to change the elements in the shallow list. So that's the difference. Matrices and vectors. You can always write vectors and matrices into the gap. So let's say a vector can be written like this. So you can say a list is a vector over here, but a matrix is not something a list. It's the so every row is a list in here. And then every element in the list is separated by comma. Every list is separated by comma. And you can write this matrix. Okay. Now, this is the weird way of looking at a matrix. So we can use the display command, and it's going to show you this. We can also use the print command. It's going to show you this only. If you want to display the matrix, you can, like the matrix form, you can use this display command. Now, if you want to if you want to multiply the vectors to the matrix, remember the multiplication should be computable. Then it's going to do that. Then a matrix to the vector, it's also true. Now you can call the elements inside the matrix again, but remember, you're not only having a list, but you have a list of lists. So what is the element 3, 3 in the matrix? 9. What is the element 1, 3 in the matrix? 3. Let's call first row, third column, 3. Second row, third column is 6. Third row, third column is 9. Okay, this is how you can call the elements. Now, inner product. You can multiply a vector with itself, and this is basically the inner product. It's going to do the inner product, and you can write the commands with hash, writing hash, and then it's going to comment and give you the inner product of a matrix, which is just 6. Okay. The operation display can be used to do this, which I have already used. Now, matrices and vectors occurring in algorithms are often made immutable, locked against changing entries. This is made to enable Gape to store certain properties without risking that an entry change would modify the property. So if it is desired to change the entries, shallow copy vector or mutable copy mate matrix returns a duplicate object that can be modified. All examples of why this is desirable is seen by the fact that a matrix, being just a list of its rows, does not copy the rows. Thus, for example, assigning the same row to a row to two matrices or to the same matrix twice and then changing this row will change both matrices. So what we are talking about is, let's say we have row which has elements 1 comma 0. Yeah, and then we have matrix 1, which has this row and 0 comma 1. So it's going to store the row as a list again if you have defined the row. But like the mate 2, let's define a mate 2 which has row is the first row and 0 comma 1 is the second row. Now first row is identical, second row is second just equal. Now when you do the mate 1, 2, 1 is 3. So you are trying to change the second row first column element as 3 and then mate, you are calling mate 1 and mate 2 also. So what's going to happen? So what have you done is when you give this command, it's going to do nothing but change the first entry is 3 and then when you call the matrix 1, it has changed the second entry, second row first entry, but not in the second one. Okay. Similarly, with same one, you can also use to change 1, 2 to 5 and then do that. Now what happened? What has just happened? The thing is, when you try to change something in the first row, row is already defined, and you are changing, row is already defined as this. Now, if you are trying to make any change to this row, mate 1 and mate 2 have same row as an first row, first list. Now, if the row changes, the change will appear in both matrices. That's the thing. Okay. Perfect. Now we will stop here and then talk about more things in the next video. Thank you so much.